Welcome back. This is your Stat Sensei for scenario 2 for the latest test that we took. And we're going to look at this question here and break it down and look at some of the common misconceptions. So the anterior cruciate ligament, the ACL, is one of the ligaments that help stabilize the knee. Surgery is often recommended if the ACL is completely torn, and recovery time from the surgery can be lengthy. A medical center developed a new procedure designed to reduce the average recovery time. This is important. They're telling us we're working with means. All right. The medical center concludes that the new procedure does reduce recovery time. To test the center's claim, a study was conducted in which 200 patients needing surgery to repair a torn ACL were randomly assigned to receive either the standard procedure or the new procedure. So we basically have 200 patients. They were randomly assigned. We don't know how that was done. And 100 received this and 100 received that. Now the question is this a paired test or is this a two sample test? Well, remember, to be a paired test, there either has to be a natural pairing or something has to be tested twice. Well, we randomly assigned them, so that means there's no natural pairing. All right, they're not twins. There's no relationship given. And we obviously didn't test them twice. We didn't fix their ACL and then tear it again and do the surgery again. So they weren't tested twice. So consequently, we have two independent groups. So this lets me know that this is a two sample procedure. And what they want us to do is use a 95% confidence interval to determine whether or not the medical center's claim is substantiated. All right. So let's look at what we need to do. Well, the first thing we do is we're going to need to define our parameters. So let mu1 equal the true population mean recovery time using the new procedure in days. All right. And let mu2 equal the true population mean recovery time using the standard procedure in days. And then we have our conditions. We have a random assignment, and that was given for both samples. And by the way, you need to tell me that it happened for both. Some people just said random assignment given. It's like, no, it's random assignment for both. And then we need to talk about the sample size. Well, we basically have 1,000. We have 100 for each one. So we need to address them separately. And the samples are less than 10% of the population. Both sample groups have 100 patients. It's reasonable to assume that there are more than 1,000 patients eligible for each type of ACL surgery. So please make sure that you don't do 200 here. All right. Make sure that you sit there and go, you know what? I'm going to look at the individual group getting it. All right. And a lot of times the group sizes will be different and you'll have no choice. So please make sure that you look at each individual group and address it as such. Independent populations, reasonable to assume that the surgery recovery time for one group will not impact that of the other. That should be true. N is 100 for both samples, which is greater than 30, the distribution of the sample means. You need to call it the distribution of the sample means. Please make sure you use this. I'll be very strict on counting that wrong in the future. So make sure that you say the distribution of the sample means. So then we need to write down our formula. And there's a lot of confusing on formula. Well, they're telling us to do a confidence interval, and we know it's two sample. We determined that. So this is our formula. All right. And so I need to start plugging into our formula. Well, we have 206 and 217. So that plugs in. I'll come back to our T star here in just a second, because there was a lot of confusion on what to do with that. Standard deviation, 43 squared, 34. Please make sure that you have your squares, your square roots. Some people were missing those things. Those were things that got points deducted. All right. So if you did not have the correct T star, you went from full credit to partial, even if everything else was shown correctly. So here's the way you get that. Let's start off with stat, test. We know we're running a two sample confidence interval. So I'm going to drop down to number 0, two sample T interval. I'm using statistics. And I'll put the sheet back up on the screen real quickly. Mean 1 was 206 with a standard deviation of 43 and a sample size of 100. The standard procedure had a mean of 270, a sample mean of 217, with a standard deviation of 34, and it had a sample size 100. And then they told us our confidence level is 0.95. When we're working with when we're working with means, we never pool, so this is going to be a no. And we calculate. All right, so at this point, I have my lower bound of 21.81 and my upper bound at 18.1863, and I have my degrees of freedom. The main reason we did this right now is we needed those degrees of freedom in order to get our T star. So there's our degrees of freedom, 188.0014. And I went ahead and wrote the interval down since I've already calculated. This is my lower bound and this is my upper bound. All right. And in this case, and I probably should have said this, I probably should have said that I want mu1 minus mu2, but this indicates that I did. All right. So when I did this, so to get my T star, this is where we're headed, is we need this T star value. To do that, I have to go second vars, inverse T. Well, my area is parenthesis 1 minus 0.95, close parenthesis, divided by 2. And my degrees of freedom is what we previously calculated of 188.0014. 188.0014. And I end up getting 1.9726. Always make it positive. All right, be positive, people. So there's my T star value. So we now have all the data entered and we've calculated it. So what can we say? Well, we are 95% confident that the true population for the difference in the mean surgery recovery times. And I went new procedure minus standard procedure, and you need to tell people which way you went, lies within the interval -21 to 0.81. Let's talk about that. That means the new procedure took less time than the standard procedure. All right, so based on this interval, it appears that the new procedure recovery time reduces recovery time. That's important. We would expect to reduce the mean recovery time anywhere from a maximum of 21 days to as few as 0.81863 days. So that answers the question, did it confirm what was asked? And yes, it does confirm what they claimed, because we said it reduces it. So make sure you always answer the question, because the question was, use a 95% to determine whether or not the medical center's claim is substantiated. And I probably should have said right here, the medical center claim is substantiated. So always make sure you answer the question. All right. In this case, we say it reduced the recovery time, and we know that it reduced it from 21 days to as few as 0.1863. We don't know where in there, but in that. So the medical center claims that the new procedure could reduce recovery time by as much as 3 weeks. Based on the confidence interval you constructed, is this claim possible? And it's like, yeah, 21 days or 3 weeks lies within the interval. We said it could reduce it from 21.8 to as low as 0.1863. All right, okay. That will conclude this video. And then this got a little awkward, so we'll move on to the next question in the next video. See you there.